Hi everyone, welcome back to Made Everything Official. Steel in its raw form is powerful, but only through heat and precision does it become the foundation of modern industry. Inside SMS Group's hot flat rolling mill, this transformation begins. Gigantic slabs of steel are heated to more than 200 degrees Celsius, glowing bright orange as they leave the reheating furnace. Each slab weighs several tons, yet here it moves with the precision of a machine-cut thread. Massive rolls apply pressure in successive stands, reducing the slab's thickness with each pass. The metal flows like liquid under controlled force, stretching and widening into long, perfect strips. Between stands, water sprays cool the surface while maintaining the steel's core temperature for accurate shaping. Sensors and automation synchronize every roll, every millisecond. The system constantly measures temperature, thickness, and flatness, ensuring consistency across the entire width of the strip. By the end of its journey, the once solid slab has become a flawless band of hot-rolled steel, smooth, uniform, and ready for further processing in cold mills, coating lines, or automotive manufacturing. This is the art of hot flat rolling, where the raw energy of molten metal meets the engineering mastery of SMS Group. Strength, precision, and motion forged together to shape the future of steel. In the world of modern engineering, there are places where technology transcends machinery, where precision becomes an art. This is BOST Machine Tools, a name that represents over a century of mechanical mastery and innovation. Here, every bolt, every surface, every rotation tells the story of how raw metal becomes perfection. Inside the BOST production halls, scale and precision coexist in perfect harmony. Gigantic cast iron bases are milled to micron-level flatness. Massive components weighing several tons are handled with silent confidence by gantry cranes and robotic manipulators. The air hums with the rhythm of progress, steel meeting steel, cutting fluid cascading across freshly machined surfaces, and high-speed spindles turning with absolute stability. From concept to completion, every BOST machine begins as a vision, then transforms into a masterpiece of engineering. Design engineers craft the geometry for strength and endurance, while mechatronic systems ensure that every axis, every motor, and every sensor responds with flawless coordination. The process is not just about removing material. It's about shaping possibilities, creating machines that can mill, bore, turn, and grind with incredible accuracy and repeatability. These machines are born to take on challenges where few others dare to operate. Gigantic turbine housings, windmill components, and aerospace-grade forgings all find their form on BOST's heavy-duty platforms. Each turning center, vertical lathe, and multitasking mill is built to absorb vibration, maintain rigidity, and deliver unmatched surface quality, even under the most demanding cutting conditions. Their frames are so robust that even a fraction of a millimeter deviation is eliminated before it can begin. At the heart of BOST's excellence lies its advanced control technology. Intelligent systems continuously monitor thermal expansion, cutting force, and real-time tool wear. Adaptive compensation keeps machining stable through long cycles, while integrated sensors ensure precision never fades, not in one part, nor in 1,000. This level of control transforms complexity into consistency, power into precision. Automation takes efficiency to new levels. Robotic systems load, position, and measure heavy workpieces with the kind of grace only machines can achieve. Tool changers operate faster than the human eye can follow, replacing cutters within seconds. Meanwhile, the digital nervous system of the machine collects every data point: temperature, vibration, and torque. ensuring predictive maintenance and zero unplanned downtime. Every BOST machine reflects decades of research, passion, and real-world experience. It carries the heritage of European engineering, a fusion of tradition and modernity. Each part is assembled by experts who understand that true quality cannot be rushed. Every surface is hand-finished, every guideway aligned with absolute precision. When the final spindle begins to rotate, what emerges is not just a product. It's a symbol of reliability, strength, and engineering beauty. At EMO, the global stage of manufacturing innovation, BOST presents its machines not merely as tools, but as the heartbeats of industry. They represent the union of technology and craftsmanship, systems capable of machining the future itself. Across aerospace, energy, transportation, and defense, these machines define what it means to build with confidence, to create without limits. From the first cut to the last inspection, every motion is calculated, every result predictable, every product flawless. This is BOST Machine Tools, where massive power meets microscopic precision and where every detail embodies one promise: engineering excellence built to last. Metal shaping begins here, where precision meets raw power. This CNC lathe operates with a CNMG 120412MR 2220 insert, performing a rough turning and facing sequence. The cutting speed reaches 180 meters per minute, removing material at a depth of 3 millimeters with a steady feed of 0.4 millimeters per revolution. Each pass generates a shower of glowing chips, pure energy sculpting cold steel into form. Once the rough phase is complete, the tool transitions seamlessly to a CNMG 120408mm 2220 insert for fine turning. Here, precision takes over. The spindle accelerates to 200 meters per minute, and the depth of cut drops to just 0.5 millimeters, maintaining a feed rate of 0.25 millimeters per revolution. Every micron is controlled, every vibration dampened. The tool path flows with surgical rhythm, cutting smooth, reflective surfaces with near-zero deviation. Finally, the system prepares for the finishing bore, the stage where tolerance becomes perfection. A pre-drilled hole of 40 millimeters opens the path, allowing the insert to refine the inner diameter. At 200 meters per minute, the lathe glides through the metal, removing only a fraction of a millimeter to achieve a mirror finish inside the bore. In the world of motion, every journey begins with precision. Nat Lucchini RS. Steel is transformed into the heart of railway performance. Wheels, axles, and complete wheel sets engineered for endurance. Each piece starts as molten steel, forged under immense pressure and shaped with exact geometry. Every contour is machined to micron accuracy, ensuring balance, strength, and flawless rotation at high speed. From heat treatment to ultrasonic inspection, every stage is a promise of reliability, a fusion of metallurgy and mechanical perfection. These are not just components. They are the silent guardians of motion, carrying thousands of tons across continents, day and night, with absolute precision. In the new era of sustainable mobility, engineering meets elegance on rails. This is the KONČAR low-floor electric multiple unit, a perfect fusion of modern design, smart energy use, and precision manufacturing. Built for quiet power and seamless performance, every train car is assembled with advanced automation and high-grade materials. From welded aluminum structures to precision bogies and electronic control systems, each element is designed for safety, comfort, and reliability. The low-floor design allows effortless boarding for every passenger, while regenerative braking and energy-efficient traction systems minimize environmental impact. Inside, digital monitoring systems track performance in real time, ensuring smooth acceleration, quiet operation, and reduced maintenance. In every skyscraper and bridge around the world, unseen heroes hold everything together. The humble bolts and nuts, small enough to fit in your hand, yet each can withstand over 40,000 pounds of force. Behind their simplicity lies a story of precision, power, and engineering mastery. It all begins with a single strand of high-carbon steel wire, coiled like a giant spring. Each coil is unrolled and straightened through a series of rollers that pull with relentless tension. The wire is coated in powdered lubricant to reduce friction, but beneath the surface lies a steel alloy built for strength and endurance. Even the tiniest bend or kink must be removed, because one imperfection could weaken the final bolt. Once straightened, the wire is drawn through a die smaller than its diameter, compressed under immense pressure until it reaches exactly 3/4 of an inch thick, the standard size for heavy structural bolts. Now perfectly aligned, it moves forward into the cold forging press, where steel takes form without heat. Each bar is cut to length and struck by a series of dies, delivering up to 75 tons of force. The first die compresses the end, forming the bolt head. The second flattens and shapes it with surgical precision. The third carves the iconic six-sided hex that allows wrenches to grip and turn. This cold process doesn't weaken the steel. It makes it stronger. Every impact tightens the molecular structure, giving the bolt its incredible tensile power. From raw steel to perfectly machined fasteners, every stage is a blend of science and precision craftsmanship. Bolts may be small, but they carry the weight of the world, holding together the frameworks of progress one thread at a time. Next comes the threading stage, where the magic of fit and function is born. Each blank is fed between two hardened steel plates, engraved with thread patterns. With a force of nearly 50 tons, the bolt is rolled, not cut. Its threads pressed into shape, grain by grain, without removing material. This rolling process enhances the bolt's density and toughness, ensuring smooth, durable threads that won't strip under pressure. Once formed, the bolts are heat-treated in twin furnaces, first at 650 degrees Fahrenheit, then at 1050 degree F, hardening the steel and locking in its inner strength. After cooling, each bolt is tested, pulled until it fails, to guarantee it meets or exceeds the 40,000-pound standard. Many go far beyond. Inside the heart of precision glass engineering, molten borosilicate is shaped with mechanical perfection. This glass-forming machine is designed for the serial production of laboratory and industrial components, from standard ground joints and ball connectors to glass threads, stopcock barrels, and precision flanges. Each tube is heated to a controlled temperature, rotating under uniform flame until the glass softens evenly. Then, using a synchronized forming head, the machine presses and molds the softened end into its desired geometry, creating female joints, necks, and custom flanges with exceptional accuracy. Depending on the model, it can handle borosilicate tubes up to 120 millimeters in diameter, ensuring dimensional stability even under continuous production cycles. The result: crystal-clear components with consistent wall thickness, perfect seals, and high chemical resistance. This is where craftsmanship meets automation, turning molten glass into standardized precision parts that define the reliability of modern laboratory and industrial equipment. In the heart of Austria's steel-hard industry, PWAG has engineered chain manufacturing for over 5 centuries. Here, high-grade alloy steel enters production link by link, forged and welded with precision. Each chain starts with a steel rod heated and formed into a robust link, then welded and meticulously inspected for strength and consistency. Advanced production equipment ensures tight tolerances and flawless welds, essential for lifting, hoisting, and industrial chain systems. At PWAG, standard isn't good enough. It's about durability, traceability, and safety in the most demanding environments. This is chain manufacturing elevated. Centuries of tradition, engineering at its strongest.